Good morning, guys. Morning, guys.
Good morning, sir.
You're fine?
So I'm fine.
Okay. Sorry for being late. I was sorting something small, but here I am. So I hope you have gone through the notes. I will just go through them quickly and maybe introduce some bit of programming. Guys, you can see my screen?
Yes.
Okay,
Yes,
good.
you can.
Okay. So as we earlier said, A computer system majorly consists of two subsystems. There is the hardware subsystem and the software subsystem. And I told you the hardware subsystem is entirely done by the electrical engineer who understands the hardware. And software, some softwares can be done by the electrical engineer, some can be done by computer scientists. For example, the operating system cannot be done by a computer scientist because to do an operating system, you need to understand the hardware. So all operating systems are designed and implemented by electrical engineers. And I started last time by saying that software tries to hide the complex hardware concepts from the user. And because the hardware, of course, understands machine language, a binary number system, that is strings of zeros and ones. So we need some software, some pieces of software to translate whatever program is running so that the hardware can understand. And that is where we talked about translators, that is the assembler, compiler, and the interpreter. And because we are adding several layers to the hardware, we are pushing the user away from the hardware and making, of course, the user view the computer system from an easily understood point of view compared to when you are dealing directly with the hardware. So the soft word is soften when we are trying to hide complexities, hardware complexities from, of course, the user. So the pair machine, which comprises of the CPU, memory, and input-output devices, once we add some layers to this pair machine, we are transiting from just this pair machine to a system. A system, of course, composed of hardware and some software. So the first layer, this inner layer here, close to the hardware, L1, of course, is composed of translators. Why translators? Because any software needs to be converted to strings of zeros and ones for the machine to understand. And of course, you don't need to have all these translators. It depends on which language the program running on the machine was written. For instance, VLC, I know you use it most of the time, is written in C++. So of course, you will need a compiler. And last time, I gave a difference between a compiler and an interpreter. We said the compiler, of course, converts the whole source code into strings of zeros and ones, while the interpreter converts the source code line by line into strings of zeros and ones. So it's the way, the difference between compiler and interpreter is the way, of course, the conversion is carried out. And of course, the assembler, we said it converts assembly code to machine code. When we talk of machine code, it's just binary numbers, zeros and ones. Sometimes there's some functions which are commonly used. For example, the sine function, there's a cosine function, the tangent, the hyperbolic tangent. All those functions, the user doesn't need to keep rewriting them. Normally, many IDEs, like the ones I will introduce today, they come with a library of functions. So the user or even the programmers don't need to be rewriting these functions. They can find them in some library of functions. So some programmer somewhere did the work and gave out these libraries for free. For example, in C++ programming, we have the math.h or CMath, which comprises of the mathematical functions. We have the C string, which of course comprises of functions that manipulate strings. And of course, there's so many, like the input-output header file, which of course contains functions for the input and output devices. So we have the CPU, the memory as the pair hardware, and of course the translators come first, and of course there are these functions, and of course they are implemented in languages, you can say C, C++, but of course they need to be translated to binary. So they cannot come in layer 1, then the translators come in layer 2. The translators are key. They come, of course, in layer 1, then the others follow. Then there are these devices, the input-output devices, which need to communicate with the hardware. And of course, we need also their utilities. We call routines. Like when you plug in a mouse to your computer, you can see something, some pop-up window saying driver, installing driver. So basically we are installing the routine for that mouse or for that keyboard. But currently these new and advanced operating systems like Windows 10, Windows 08, Linux, we have Android, they normally come with very many routines for these input-output devices. So nowadays, it's very hard to see when you plug your mouse or your keyboard to your computer, if you are running Windows 10, to see such a pop-up window saying maybe keyboard driver installing or monitor in a driver installing. So normally the programmers for these operating systems, they have packaged so many routines, input-output routines into the system so that the user finds it easier to use the operating system. It doesn't need to go looking for these drivers, So we have translators now, a library of functions, routines. And you go this way until you reach the operating system. And now the operating system is where the user interacts with the computer system. An operating system is also, of course, a program written in C for speed. You want to run, you don't want to have an operating system which runs, of course, slowly. So you have to implement it in C, which runs or which executes faster compared to an operating system written in Java or written in C++. So the operating system is what the user interacts with. But the operating systems acts as a link between the user and the hardware. Let's say you are using or you want to launch VLC. And we know VLC will utilize the speaker, computer speaker, will utilize the RAM, will utilize the screen. So the operating system, once you launch that application, which of course resides on top of the operating system, it will identify the resources required by the VLC. I've talked of the speakers. I've talked about the screen. I've talked about the RAM. So the operating system will do what we call time slotting to the VLC to utilize these resources. And because of this concept called time slotting, we can run so many applications in a computer. You can be running Gmail at the same time. You can be typing some work in Word. You can be listening to music. All those applications are utilizing the limited hardware resources. But because the operating system creates several time slots for these applications, and it will be allocating them, let's say VLC time slot 1, the Gmail time slot 2, the Word time slot 3, and you can have so many applications running. So once they have been given those time slots, they will be running, and once they finish whatever task they are doing, they will return, or they will signal the operating system that, of course, we have finished running whatever we were doing. You can take the time slot back. So there is so much to do. I will introduce the operating systems further so that you can understand what it entails. And somebody last time asked me this object code, whether the file, when we convert or when we translate the source file, do we get an object code? Yes. The right name is object code, which is, of course, a string of zeros and ones. So the object code is just strings of zeros and ones. The source code can be a program in any language. It can be Java, it can be C, it can be C++, it can be Python. But once we translate, we will have an object code. But because sometimes these big programs, we will have so many source files, what we call source listing, then, of course, we will have what we call an object file, and all of them will be linked. And we'll learn that when we start programming. So the operating system is sometimes termed as the system software, and whatever you runs on the operating system is what we call the application software. So you can see the hardware is there, then the operating system, then of course the application software, which the user launches, and the operating system creates time slots for them. And I've given an example there. Very well. Any question, guys? Any question? Any question, guys? Guys, are you getting me?
Yes.
Yes.
Any question, guys?
Yes.
Any question, please?
A question.
Yes. Who is speaking? Oh, Nicole. Yes.
It's Victor.
It's Victor.
Yes, I have a question.
Yes. Ask.
In the examination, can they ask you to describe the software layers? And if they do, what will they expect you to perhaps bring out?
Yeah, you can be asked the layers of the operating system. And you can be asked like what the individual layers or operating systems units do. For example, you can have the driver unit, you can have those translator unit. All of them come under the operating system. So you can be asked what they do, those kind of layers. So it's good to study and understand the various layers of the operating system.
Well, thank you.
Yes, another question? Uba. Any question? Is Uba in the class?
Yes, I'm here.
You don't have question?
No, I don't have.
Any other question, guys? Oh, time slots. Nicholas, yes. Time slots, assume you have a room. They say you have a room. And this room is supposed to be occupied by one person. So you give this person some time to finish before you let in another. But it is also possible you allow person one to do a few things, you transfer that control to person two, and it does a few operations before you come to person one. So time slot means you are allocating a given application, a given application to run before you transfer the control to another application. And you do it in a round robin way. I don't know if I'm getting what was this guy? Nicholas. Nicholas?
Yes.
Are you understanding what I mean by time slots?
Yeah, I think I'm getting something.
So can you explain in your simple language? Maybe you can understand your colleague. You can help your colleagues understand.
Okay, let me try.
Yeah, go
Well,
on.
you've said
Yes.
when the operating system locates time slot, it simply means that it allows a particular operation to run for a given
Yes.
period of time before giving control over to another application.
Yes, let's say we have a VLC and we have Gmail, okay? And your computer, mind you, is clocking at a very high frequency. That's why we talk of a 3.0 gigahertz processor, 3.2 gigahertz. So they will be switching so fast that you might think all of them are running at the same time. Up to that point, am I clear, Nicholas?
Yes.
So imagine you are doing so many applications, or you are running so many applications, but you are doing the transfer at a very high rate. So to a user, they will assume that all of them are running at the same time. A very good example, you know the bulb, AC bulb. Class, you know the bulb, AC bulb? A bulb. Class, you know an AC bulb? Nicholas?
An AC bulb, yes.
Bulb, a bulb. Tar.
Yes.
Yeah, now I'm asking and you're keeping quiet. Okay, what frequency is our AC power? At what frequency? If you have been keen, who can try?
50 hertz.
Very good, 50 hertz. So what is that period? What is the period? Frequency is the reciprocal of time. Yes.
0.02 seconds.
So imagine the power is changing at the rate of 0.02 seconds. But if you look at the bulb, does it dim? Does it appear like it's dimming?
No.
It doesn't appear dimming because it's switching at a very high frequency, 50 Hz. Not very high, but to the human eye, it's relatively fast. So it's doing at 0.02. So now imagine the processor which is switching things or doing operations at 3.5 gigahertz. So what will be the period if frequency is 3.5 gigahertz? Who can try? It's the same thing. T is 1 over F. Who can try? Kifuva Kialo. Kifuva?
Yes, sir.
So what
Yes.
is the time? Giga is 10 to power. What is giga? Is it 10 to power 9? You guys, you have not done enough maths. Chalo, is 10 to power?
2.859.
Giga is 10 to power 9, is it?
Yeah.
Who is speaking? I could love to know who is that speaking.
Masinzilani.
Mercy.
Yeah.
Maingi, is it?
Yeah.
Yes. Now, what is the period if the frequency is 3.5 gigahertz?
2.86.
What?
2.86 hertz.
My friend, that is already in frequency and you are giving me an answer in frequency. Time is the reciprocal of frequency. I've given you the frequency of 3.5 gigahertz, which is the same as 3.5 times 10 to power 9, is it?
Yes.
So what is the time? The time is 1 over F. Martin Choi, you want to try?
Yeah, 2.86 to 10 power negative.
10 negative 9 seconds, is it?
Yes.
So what is 10 negative 9? Is it nano? Is it nanoseconds?
Yes.
So it is doing at 2.9 nanoseconds. So that's very fast. So if you have even 10 applications running concurrently, you will see that all of them are running at the same time, but they are being switched at that high rate by the concept called time slots. Time slots. Is it okay, class?
Yes, sir.
Yes.
Yes.
Any other question? I will explain more the concept of time. And there was a question here, by the way. Sir, what are those layers of the operating system? Are they the hardware? The hardware is not part of the operating system. From today, know that the hardware is not part of the operating system. But the translators, the library of functions, the routines are part of the operating system. Maingi. Maingi,
Yes.
have you understood?
Yes.
The hardware is not part of the operating system, but the translators, the library of functions, and the routines can be units of the operating system. And of course, different layers constitute different operating systems. For example, the layers of Linux operating systems are different from the layers of Windows operating system. Am I clear? Am I clear? Am I clear, class?
I have a question.
Yes.
Yes.
Somebody ask a question. You can go on and ask. Yes.
Excuse me, sir. So what are those examples of the layers of the operating
I've
system?
said the translators can be part of the operating system. I've said the routines can be part of the operating system. The library of functions can be part of the operating system.
Thank you.
So it is what you add to the, it's what you add as layers that will differentiate one operating system from another. Okay? So when we come to, we will compare, for example, Linux operating system and Windows operating system later on, but not now. But just know that at this level, Windows operating system has some layers different from the Linux operating system. Am I clear, class?
Yes.
Yes.
Any other question, please? Feel free to ask. In case of all, yes, yes. Who is speaking?
Dorlong. I'm asking.
Yes.
My name is Dor. I'm asking what
Dor,
is
yes.
the difference between compiler and interpreter?
My friend, were
I
you
didn't
there?
get it well. The difference between
Last time.
compiler.
What's your name? Dejango. Are you Dejango? Okay. Last
Yes.
time, okay, understand this. All of them are translators. Assembler, compiler, and interpreter, all of them are what? Translators. Basically, they translate one language to another. Okay? Assembler translates assembly code or code written in assembly language to machine code. Compiler translates high-level languages, source code like C, C++ into machine code. And how does it translate? Compilers, they take the old source code and convert it to a machine code and what we have called an object code. All of it, all of it. But when we talk about interpreter, they convert the source code, which is in high-level language, line by line, line by line, line by line. Compilers translate the whole source code, all of it, all the lines into a machine code. Compilers, interpreters translate, if you have 1,000 lines in a source code, they will translate line 1 first, followed by line 2, followed by line 3, like that, up to the end. But the compiler will pick the whole 1,000 lines and convert to a source code, to machine code. Am I clear, Orar? Was it Orar? Chedango? Chedango?
It is clear. Thank you.
It's clear. Okay.
Yes, sir. It is
Another
clear.
question, please.
It's clear. Thank you.
Another question, please. So we are good. Can I do some introduction of programming?
Yes.
Okay. The first thing you need to learn, I gave you the site that we'll be using. It's called Programmist C++. This site, you can see there is an introduction to C++. And of course, C++ for all games. If you are fans of gaming, you can, you love playing games on your phone, on your computer. All those games are written in C++. And even some applications that run fast, like VLC, is written in C++. Even Gmail, they are written in C++ for speed reasons. And the difference between C and C++, C++ is object-oriented. What do I mean by that? For instance, in life, you can have a teacher and a student. So in your class, I told you a good engineer is an observer of nature. In your class, you have a student and a lecturer. But the student can have different names of students. So you can have an object called student, but under the student, you can have the registration number, the gender, and things like that, which you cannot do in C. In C, you can only write a few functions. And we'll cover that when we come to functions. But when we do object-oriented, you will differentiate between a function and a class or an object. So the first thing you need to do to learn this programming, you install code blocks. So you go to your email, not Gmail, but your Google search and search this code blocks IDE. Let me show you. You search for code blocks IDE and then you open. Once you open, am I clear, class? Are you following?
No.
Yes, we are following, sir.
So to program, you need an IDE, Integrated Development Environment, where you will be writing your source code. And the source, yes, please go on. Somebody was asking a question. Emmanuel, yes. Emmanuel? Emmanuel, are you asking a question? Somebody is asking, I resend okay. So let me post it in our chat. Whatever I've posted is the code blocks website. So you go to that link and you download the following. You go to downloads, click on downloads. Let me see. You go to binaries, downloads, binaries, and you download. If you have a 64-bit machine, you can download this. It runs both. Actually, this is what you should download. Code blocks 20.03 Ming setup .exe. So this one here. This one. You can see, class?
No.
No.
Yeah,
Are
very
you-
tiny.
Oh, it's tiny.
Yeah.
So can I post the, you can see?
No, we can't see it.
No.
Sorry.
So can I share the link?
Yeah, share the link.
Okay. Just go to this link. It's within the same website I gave on. And you go to download section, then binaries. You want me to zoom? How can I zoom this now? Let me see. You can see now, I've zoomed. Can you be able to see now? Class? Can you see my screen now?
Yes.
Is it clear now? You can see? So you download this one, Code Blocks. This one. And you can download it from these links. Use sourceforge.net. Sourceforge.net. So if you go to this website, sourceforge.net, it will just download automatically. Yeah, but I'd already downloaded. So download that and install in your computer. Install it in your computer. Yes, question, please. Question?
Is it possible for us to use other applications other than code blocks?
Yeah, you can use other applications, but I've been using code blocks. It's good to all of us to use the same IDE, because if we have challenges, then we can be able to understand each other. But if you are good with another IDE, you can use it. So I want you to install that. I want you to install that IDE. And once you install, I want you to, am I clear? Class?
Yes, I have another question.
Yes.
Is it possible that when we resume in-person learning, we can use the computers provided by the school?
Yeah, we can use that, but you see now at the moment, okay, let me, from my experience, this is what I know. Computers in the lab, you cannot use them maximally, or they cannot enable you to learn programming. You need to have your own computer, which you can carry to your room and program wherever you are. So if you are limited with what we have in the lab, remember, you'll be going to the lab, and sometimes other students will be using the lab. So I recommend you buy your own laptop. Is it clear? For flexibility and you have more time to learn, it's good to have your own laptop.
Yes.
Ismail, you are saying you can't see. Which screen? I hope, can you see the Code Blocks website? Ishmael?
No, I cannot see it.
Why? Class, are you seeing my Code Blocks website? Can you be able to see my, let me present again. You can see it now?
Yes, I can see it.
Yeah, so you go to this website. Let me copy the link. So this is the link for the SourceForge, and you can download from there. So the first task, class, go download that software, install it in your computer. Install that software in your computer. And once you install, let me open my code blocks. I'm trying to open code blocks. You can see my screen of code blocks. Class?
Yes. We can.
Okay, so I want you to install, and once you launch it, of course, or once you open it, you will see that. And the first thing I want you to do is you come here, you create a new project. You click on that and you select console application. Console application. Create a new project, console application. Then you go. This one you can skip. And you don't select C, you select C++. And you give it the first one. You can give it a name, let's say fast, C++, program. And you can create a folder in your desktop where you will be storing your programs. And then you go to next. Of course, you should have a GNU GCC compiler. GNU GCC compiler. GNU GCC compiler. Then you finish. And then under the sources, on your left, you will have this function called main. I want you to be at this point. I want you to navigate until you reach this point. And then, of course, you can come here, you build. And you can check that you don't have any errors. And then you can see now, I have my program, Hello World. Hello World. So I want you to display that, to do that simple example.
Excuse me, sir.
Yes.
Is it possible that you start again once more?
Eh?
You start once more.
I start.
Yeah.
I start from which point?
The first step.
Of writing the program.
No.
Hello?
Of the source file.
I'm not
Of
seeing
the
the
code
screen,
block.
sir.
Eh?
Yes.
Kivuva. Who is speaking? Is it Kivuva?
Yes.
So you want me to start from what point?
Downloading the code blocks.
Okay. So you go to this site. I've shared the site already on our group. You can see the HTTPS sourceforge.net. You can see that?
No.
It's on the charts. I posted on the chats.
Pardon?
Kivuva, I've reposted.
Yes, I can see it.
You can see it.
Yes.
So you go to that site,
Yes.
download the CodeBlocks IDE. Up to that point, are we together?
Yes.
Download the CodeBlocks IDE. Tuko sawa?
Yes.
The next thing is install. The next thing is install. The next thing is you install. Install it on the computer and then you launch it. Once you launch it, CodeBlocks. You launch it and you create a project. You can see now Kivuva at this point.
Yes.
You can see my CodeBlocks.
Yes.
So you create a new project. Are we to get up to that point?
Yes.
So you create a new project, console application. Once you click create new project, you select console application. Go. Select C++ and not C, C++. You can call it first or even second or C++. Program. And you can create a folder where you want to store your functions. Next. Then you finish. You go to sources. There you have this function. I want you to be at this point. And then you run. You come, you build. You checking that you don't have errors. I hope you can see what I highlighted. And then you run. There you have your hello world. Console application means you don't have graphics.
Hello, sir. I'm not seeing the screen. It's very tiny. I'm not even seeing it well, what you are writing.
I'm not writing. What you do, the first thing, go install CodeBlocks. Hapo tumeelewana? Install CodeBlocks. Create a new project, console application. The first thing, look for CodeBlocks, install. How many have installed CodeBlocks? Who has tried and installed in the class?
I have tried.
Who has tried? Mutuku. Mutuku.
Yes.
Have you reached where I've reached?
Yes.
Can you run and combine?
Yes.
good. Assist your friends. How many? Let me see in the chat. How many have installed? Mutuku, very good. Ngesa, very good. Chevua, Hussein, I can see you have installed. Very good. Chui, Eva, where are you? Have
I'm
you
here.
installed?
It's still
Very
in the
good. Guys have done. Guys have done it. So try and run that code. Try and run that code. Assist your fellow guys to reach where I've reached or where you have reached. The next time we will explain what that function is doing. Is it clear, class? Lumasai? Ashley, is it Lumasai? Lumasai? Put your mic close. You can hear me? That's very good. I can see you have done it. So I have how many? 1, 2, 3, 4, 5, 6, 7. 7 have done it the first trial and they have got it. Assist your friends to get it done. So every Wednesday we'll be doing programming. Every Tuesday I'll be teaching. Is it clear, class? Abdi, class rep?
It's clear. It's clear, sir.
Yeah, so make sure they have that information. Tuesdays I'll be teaching. Wednesdays we can be doing some programming.
So we're supposed to install a compiler.
Apana. CodeBlocks comes with a compiler. That's why it's called an integrated development environment. It's an IDE. CodeBlocks is an IDE, integrated development environment. It comes with a compiler. Is it clear? Or are you getting some error? Uba, are you getting some error?
No, sir, I'm getting no error.
Okay, then. It
It's
comes
clear.
with the compiler. Okay. It comes with the compiler. Martin Chue. Guys, help this guy. You know, when you help each other is when you get to learn. Help each one of you to get the code blocks running so that we can start next time. So allow me leave, guys. All the best. I'll try and do some notes and I will share. Are you finding the notes? Any comments, please? The notes?
They are good.
They are very simple. I try to make them simple so that you can understand. So read and research more. Is it okay? Class?
Yes.
So kindly read more, assist your friends to install CodeBlocks. So next Wednesday, we'll write some more code, but make sure you are able to print the Hello World on the console application. All the best. So we meet, I will send the notes, I'll try this week by Friday. Today is Wednesday. You know, I'm doing so many things.
Sir, before you go,
Yes.
where are we supposed to store the file, the file?
You create
an error about the file.
Eh?
I'm getting an error about the file.
The path.
Yeah, the path for the file. So are we supposed
The path
to
for what?
for the file, where the file is supposed to be saved?
Which, okay, what you do is this, Which error? Can you post it here? Can you be able to post the who is speaking in the first place?
Martin.
Martin,
Yes.
can you post your error on this chat?
Yeah, yes.
Post.
I'm getting a difficulty in posting it. Elias is one of the person who has done it.
Yeah, just liars with your colleagues. They will assist you. You know, when you assist each other, you learn more.
Yeah.
Couldn't create project. Those ones you can solve. It's maybe the way you are doing it. Assist others, so that they learn. So allow me leave. When you solve your own errors is when you learn more. So kindly try and solve them. All the best. Next week we can do some more programming. So allow me leave, please. I'll try and do some
Okay,
more.
thank you.
Yes.
Good day.
Who is
We will try.
speaking?
We will try.
Who is
The
speaking?
Django.
Ah, very good. Very good.
Yeah.
You try and make sure your code blocks is running.
Okay, thank you.
And read the notes and the book.
Okay.
Good day, guys. All the best. Keep safe.